Welcome to the Explainer. Look, today we're unlocking a totally new level of productivity for your dev team. We're going to see how to make OpenAI's Codex work significantly faster and honestly just a whole lot smarter for you. If you've been using Codex, you already know it's incredibly powerful. But today, we're moving way past relying on just a single general-purpose AI. Instead, we're talking about coordinating a massive, highly specialized team of virtual experts.
Okay, let's dive into this. We're going on a bit of a structured journey today, starting with the subagent setup problem, looking at 136 ready-made Codex experts, breaking down the anatomy of a Codex subagent, and then getting into smart routing and sandbox guardrails. Finally, we'll wrap up by deploying multi-agent workflows and supercharging everything with CSV batching.
Section 1. The subagent setup problem. Friction in configuration.
So here's the central pain point for software teams. Why build Codex subagents from scratch? I mean, we all know Codex is a phenomenal generalist. Out of the box, it kind of does a bit of everything, right? But when you need it to execute highly specialized tasks, think like an exhaustive security audit or some complex database migration, relying on that default generalist setting just isn't going to cut it. You need custom subagents. But the real headache? Building these specialized agents from the ground up is incredibly tedious work. You're literally reinventing the wheel for every single role you need.
The friction is totally real here. To build just one custom subagent, your team has to write detailed toml config files, make complex model routing decisions, define strict sandbox modes, and on top of all that, execute highly sophisticated prompt engineering. Because of this massive overhead, let's be real, most teams just give up. They settle for a few ad hoc scripts, or they stick to the defaults. And by doing that, they're completely missing out on Codex's true potential to act as a fully orchestrated team of specialists.
Section 2. 136 ready-made Codex experts, the Volt Agent solution.
This right here is where all that friction just disappears. 136. That's the magic number today. There's a community-maintained open-source repository called awesome-codex-subagents, and they have done all the heavy lifting for you. This repo gives you a plug-and-play team of exactly 136 highly specialized AI engineers, security auditors, data analysts, and QA testers that you can instantly drop right into your codebase. You don't have to write the prompts, you don't have to configure the guardrails. These experts are already built, tested, and ready to hire on the spot.
Now, what's really interesting about this is the sheer breadth of these experts. They're organized across 10 major categories. You've got your core dev agents like backend developers. You have infrastructure specialists like Terraform engineers. There are quality and security auditors, plus developer experience agents that can entirely manage your Git workflow. And it goes even deeper. There are whole categories for data and AI, and even meta-orchestration agents whose entire job is just to coordinate the other agents. Whatever hyper-niche problem you're facing, there is almost certainly an agent tuned specifically to solve it. Section 3. Anatomy of a Codex subagent. Under the hood.
So, let's actually define how these things operate natively in Codex. Basically, a Codex subagent is a standalone toml configuration file, just a simple text file, that defines a specialized AI assistant. The absolute beauty of this architecture is that every single subagent operates within its own completely isolated context space, and this is absolutely crucial because it prevents cross-contamination. Say your backend subagent is knee-deep in complex server logic, while it's not going to pollute the context window of your main UI conversation thread.
Diving into the schema itself, these toml files basically act as direct configuration layers whenever you spawn a new session. Every file requires a name, a description to guide Codex on when to actually use it, and developer_instructions. Those instructions are the core behavioral rules that keep the agent strictly focused on its one specific job. Then, you've got optional but super powerful fields like model to override the target AI model and sandbox mode, which defines exactly what level of access the specific agent has to your file system.
Section 4. Smart routing and sandbox guardrails, security and cost efficiency. First up, let's talk about where these agents actually live and how Codex prioritizes them. You can install agents globally in your home directory, which makes them available across all your projects. Or you can install them as project scoped agents directly inside your specific repository's .codex folder. The golden rule to remember here is precedence. Project-specific agents always have higher precedence. So, if there's ever a naming conflict between a global agent and a project agent, Codex is just going to silently override the global one and use your project scope version.
And this brilliantly illustrates how you can manage costs without sacrificing quality. Two-tier smart model routing. Let's face it, not every task needs the most expensive, heavy-duty AI model. For deep reasoning tasks, architecture reviews or complex security audits, the subagent's toml file routes it straight to the high-tier GPT 5.4 model. But for fast, lightweight stuff like codebase scanning, researching docs, or handling an installation, it automatically routes to the faster, way cheaper GPT 5.3 Codex Spark model. It's a perfect balance of deep reasoning and fast, low-cost synthesis.
Now, if you're feeling a little nervous about letting autonomous agents just run loose in your codebase, honestly, don't be. Security is baked right into these subagents via sandbox mode. Take a security-sensitive agent like an auditor. It's explicitly hard-coded to read-only in its config. It can analyze your code all day long, but it literally cannot modify a single line. On the flip side, a front-end developer agent is granted workspace write access, so it can actually scaffold files and write the code. This explicitly limits the blast radius of specialized agents right at the point of installation.
Section 5. Deploying multi-agent workflows, moving from theory to practice.
The installation process here is incredibly simple. Step 1, you clone the awesome-codex-subagents repository. Step 2, you copy the target toml files you want into either your global or project-scoped agents directory. But step 3? This is the most important thing to learn today. Codex does not automatically spawn these custom subagents for you. You have to explicitly delegate the work to them in your prompt. You're the manager here. You have to tell Codex exactly which agent to call into the room.
So here's what an explicit multi-agent workflow actually looks like for a real-world pull request review. Instead of asking one general AI to review your code, you orchestrate 3. First, you prompt the PR Explorer agent to map out the codebase and gather evidence. Then you pass that context over to the reviewer agent to check for correctness, plus security and regression risks. Finally, you have the docs researcher verify your code against the absolute latest framework documentation. By splitting the task up like this, you ensure every single agent stays incredibly narrow, opinionated, and highly accurate.
Section 6. Supercharging with CSV batching, the power feature.
So the crucial point here is this experimental feature called spawn_agents_on CSV. This command is a real game changer because it unlocks massive automated batch processing for your code base. It literally allows Codex to read a CSV file, spawn one isolated worker subagent for every single row in that file simultaneously, wait for all of them to finish their work, and then seamlessly export the combined results straight back into a new CSV.
Think about it. This is absolutely perfect for when you have a list of hundreds of files to audit or you're running a massive service migration. You just feed it the CSV, and Codex dynamically injects your column names right into the prompt template for each worker. You can even enforce a fixed JSON output schema, meaning every single worker returns data in the exact same format. Under the hood, it uses a SQLite-backed state. So even if one worker fails for some reason, the job tracking remains totally reliable and errors are cleanly logged in your final export. It's basically an industrial-scale code refactoring tool.
As we start to wrap things up, it is important to impartially read the open source disclaimer provided by the repository maintainers. Quote, "All subagents are provided as is without warranty. We do not audit or guarantee the security or correctness of any subagent. Review before use. The maintainers accept no liability for any issues arising from their use." So, definitely make sure you review these tools and adhere to your own organization's internal governance and security policies before deploying them into production environments.
And that brings us to the end of the explainer. We've seen how to eliminate configuration friction, manage costs with smart routing, protect our environments using sandbox modes, and scale up massively with CSV batching. So I'll leave you with this final thought. With 136 specialists sitting on the bench waiting for your call, which expert are you dropping into your code base today? Thanks for joining us, and have fun building your new AI team.